Hi, I'm Tommy from Group 2. This is our progress presentation on our IoT application or the smart car parking system. So I will have a quick introduction about what we were talking uh, in this presentation. First, we will talk some functional specification, and then objectives, and then architecture on both hardware and software, and the last for the future tasks. So in general, our car parking system can do some function like detect each slot where the slot is occupied or not, and then each slot can will have a LED in dedicated light on the top of the slot, so it can show the status of that slot to the drivers. Then the system can calculate the number of empty slot. Uh, the most important thing is based on this system, it can output some information for the user in a visualized way, so the user can read about this information very easily.
I'm Jasmine and I will introduce the objectives and the hardware architecture of our car parking system. We have 7 objectives for this project. The first 3 objectives are about the design and the implementation. We have to design the system feature, which is to design and confirm the functionalities of our system. Then, we should design the hardware and software architecture of it and start the implementation of the hardware and software design. While doing the implementation, we should study the electronic components to make sure all the components can work with proper installation. We should also test our hardware to determine is it fulfilling the running requirements. Also, we should verify the system that is reached the expectations. And we should analyze the difficulties of the system by some case testing. So from this stage, we have finished the phase of design and component analyzing, and we are progressing on the implementation and testing. The following objectives will be conducted in the future. So next, I'm going to introduce the hardware architecture of our system. As the effect of the coronavirus, we have to compute our hardware prototyping using Tinkercad. Since there are some limitations on Tinkercad, we have cancelled some components we designed to use before. The cancelled components are camera, LoRa transceiver, and LoRa gateway, and the EPS32 Wi-Fi module. Since Tinkercad does not provide these components, or they are not functionable on Tinkercad. For simulating our system on Tinkercad, we would like to contain the following components. Arduino Uno R3 is the microprocessor we are using, having 40-digit input or output pins to read or transmit signals. We are going to display message by using the LCD panel, and the ultrasonic distance sensor will be using to detect the distance of the object, simulating the system of detecting the available parking spaces. An LED will be used the signal from the sensor to determine the on-off operation. Resistor, potentiometer, and breadboard are also designed to use as to complete the circuit. Servo motor will be inserted to the circuit in the future tasks. So this is the connection of the modules. For connecting the LCD panel, we have assigned 6 digital pins from module. As our LCD pins is in 4-bit mode, we only need to assign 4 data bus pins to the microprocessor. The data bus of LCD DP4 to DP7 is connected to the digital pins from D2 to D5. Enable pin is connected to D11 and RS pin is connected to D12. Read and write pin is connected to the ground and VE is connected to the potentiometer. For the ultrasonic distance sensor, only 3 pins need to be assigned. Apart from the ground and the power supply, signal pins is needed to connect the microprocessor. These 2 sensors is assigned pin to the pin D7 and D8 from Arduino. LED must receive the signal to control the on-off operation. We have assigned digital D6 and D13 to the 2 LED to the 2 red LED. The anode of the LED must connect to the 220 ohms resistor first, but not just directly connect to the Arduino. So I will let my groupmate to introduce the key consideration of our system design.
Hi, I am Sophia. Now I will talk about the key considerations of our car parking system. Firstly, we consider about the stability of the LCD panel. In order to have a stable display on the panel, we set a delay time of 3 seconds in the function called loop, so that the LCD panel can update the information in every 3 seconds, and it can have a stabilized display. And for the second consideration, we consider about the brightness of the LCD panel. To ensure the panel can display in a more clearer and brighter way, we add a potentiometer in our circuits to control the brightness of the LCD panel. And when we switch on this potentiometer, the LCD panel will switch on accordingly. And thirdly, we consider about the detection of the ultra-distance sensors. In our system, we have 2 sensors. In the program part, we set pin 7 as the trigger and echo pin of sensor 1, and pin 8 as the trigger and echo pin for sensor 2. In this function called check slots, we generate a pulse and calculate the distance of the object. And in this function, we generate a pulse so that the sensor will keep detect an object continuously. And in the second function called check space, in the if case, we set that if an object or a car is detected within the range of 2 cm to 300 cm, and it means that the car is occupying the space, then the function will return true. Otherwise, it will always return false. And these 2 functions will be added in the loop function so that the system will keep the distance sensors will keep detect the cars continuously once the system turned on. And for the last consideration, we consider about the reactions of the red LEDs and the LCD panel. And once a parking slot was was occupied by a car, the LCD should light up and the red LEDs should be lighted up, and the LCD panel should update its information immediately. And in order to solve this problem, we set pin 6 and pin 13 as the LED outputs of the LEDs, of the two red LEDs, and we set the LCD settings in the setup function. And then we create a function for the LED called the so-called the LED. In the if case, it mentions that if the sensor detects an object, the LED should be lightened up. Otherwise, it will always switched off. And this this LED function was also applied in our loop function.
So about the software architecture, this figure shows the relation between hardware, server and database. When the hardware generates some input and it will send to our server through some HTTP protocol. Now I'm focusing on handling the data and put it on the database. So I have built up some roles for the data handling. So what is about the role? I have a very simple example on here. This URL is what I call the road. If I wish to get some data about the sensor, I can get the data through this HTTP get function. So I can have some data about the sensor. It is now week 6. For the recent 2 weeks, we will continue doing on hardware prototyping and software implementation. After that, we will integrate the whole system together, and then we will have some verification and testing on the system, and then debug the whole system and make it perfect. So basically, this is what we will do for the remaining time. This is the whole presentation we have. So thank you.